in the next part we will learn about power. What is power? Power is basically the rate of doing work. That is, power equals to work done by time. That means, what are the factors on which power depends? Power basically depends on the amount of work done and the time taken for the work to be done. SI unit of power. SI unit of power. SI unit of work done. Equals to joule, and SI unit of time equals to second. Therefore, SI unit of power equals to 1 joule by 1 second. That is 1 joule per second. It is also known as watt. Okay. The bigger unit of power is kilowatt. 1 kilowatt equals to 1000 watt. Okay. The other unit of power is horsepower. 1 HP equals to 746 watt. Is that clear? Okay. Now we will learn about the relation between power, force, and average velocity. Relation between power, force, and average velocity. Okay. P equals to W by T. That is work done by time. And what can I write? Work done equals to force into displacement by time. Okay. So we can write P equals to F into S by T, where F stands for force, S stands for displacement, and T stands for time. So we can say F equals to S by T, that is V, or the average velocity. Therefore we can say power equals to force into average velocity. Is that clear, everyone? Now we will learn about energy. What is energy? Energy it is basically the capacity of doing work. The SI unit and CGS unit of work done and energy are same. We will learn about many types of energy. There are various types of energy. We can say there are mechanical energy, chemical energy, nuclear energy, solar energy, sound energy, heat energy, whatever. In this part, we will learn about mechanical energy. What is mechanical energy? Mechanical energy. The energy possessed by a body by virtue of its motion as well as configuration. That is energy at rest or in motion. There are two types of energy. One is the potential energy. The kinetic energy. This is mainly energy at rest, and this is energy in motion. Okay, these are the two types of mechanical energy. Potential energy can be also classified. Potential energy can also be classified under two categories. Number one, elastic potential. Number two, gravitational potential. Basically, this potential energy is based on the position of the body. And elastic potential is basically based upon configuration. Configuration means shape and size. That is shape and size. Kinetic energy. We know that kinetic energy is the energy possessed by a body by virtue of its motion. Okay, so by virtue of its motion. The formula of potential energy is mgh, and the formula of kinetic energy is half mv square. Now, how we will derive the formula of potential energy as well as kinetic energy? Just now we have discussed that work and energy are numerically same. So, energy, that is potential energy, equals to F into S. As we have discussed that potential energy is basically based upon the position of the body. Therefore, we can say that the body force equals to weight of the body, and displacement is the height at which the body is placed. Weight means mass into acceleration due to gravity, and the displacement or the height is h. Therefore, we can say PE equals to m into g into h. Is that clear, everybody? Now we will learn how can we get the formula of kinetic energy. Basically, kinetic energy means half mv square. Now we will consider, actually when we will talk about kinetic energy, we will talk about retarding force. Retarding force means the final velocity will be 0. That is v equals to 0. The initial velocity will be considered as v, and the acceleration is negative. Now we know that v square equals to u square minus 2as. Now we will substitute the values from this above. V means 0, that is 0 equals to, u will be substituted by v square minus 2as, or v square equals to 2s, or v square by 2a equals to s. Okay. Now work done equals to force into displacement. Fine. Force means m into a, that is mass into acceleration, and s equals to v square by 2a. We will cancel a, that is half mv square. The question also arises, what will happen if the velocity is doubled? If the velocity is doubled, then the kinetic energy will be 4 times. Okay. Now we will discuss about the relationship between momentum and kinetic energy. Relationship between momentum and kinetic energy. Momentum, that is m into v. Okay. Kinetic energy. Momentum means P equals to mv, and K equals to half mv square. So we can write P by m equals to v. And now we will substitute the value of v here. That is Ke equals to half m into p by m whole square. That is Ke equals to half into m into p square by m square. We cancel out m. Therefore, 2 Ke equals to p square by m, or 2 Kem equals to p square, or root over 2 Ke into m equals to p. So this is the relationship between momentum and kinetic energy.